Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll introduce you to AWS Glue, Amazon's fully managed serverless data integration service. We'll cover the fundamentals, like the Glue data catalog, crawlers, ETL jobs, and triggers, and visual tools like Glue Studio and Data Brew to build ETL pipelines without provisioning infrastructure, and apply best practices around performance, cost optimization, and security. Let's get started. Modern data teams face challenges that go far beyond traditional ETL tools. Let's break down what's really happening in the data landscape today. First, traditional ETL pipelines are rigid and outdated. They often depend on fixed schemas, long batch windows, and manual orchestration. Anytime a data source changes or a new format is introduced, it's a major rework. One of the biggest headaches is schema drift, when the structure of incoming data evolves over time. A missing field here, a renamed column there, and suddenly your pipeline breaks, or worse, corrupts your data silently. At the same time, data is coming from everywhere. APIs, IoT devices, SaaS platforms, on-prem systems, each with their own structure, frequency, and format. We're no longer just dealing with rows and columns, we're dealing with nested JSON, streaming logs, and time series data. These diverse datasets often sit in isolated silos, locked away in specific applications or cloud services. Getting a 360-degree view of your customer or business operations means breaking down those silos and stitching together inconsistent data. And then there's scale. As your data grows from gigabytes to terabytes and beyond, the cost and complexity of managing infrastructure, scaling clusters, and tuning jobs manually becomes unsustainable. Expectations are also changing. Business users and analysts want fresh data, often in near real time. But legacy systems were built for daily batch jobs, not minute-by-minute updates. Add to that the increasing pressure around data security, compliance, and governance. Data teams must now answer questions like, who accessed this dataset? When did it change? Is it compliant with GDPR or HIPAA? All of this leads to a clear conclusion. We need modern, cloud-native, serverless data integration tools, solutions that are flexible, scalable, cost-effective, and secure by design. And that's where AWS Glue comes in. AWS Glue is Amazon's fully managed serverless data integration service. It's designed to make it easy for data engineers to prepare and transform data for analytics, machine learning, and real-time applications, without having to manage infrastructure or worry about scalability. At the heart of Glue is its serverless architecture. That means no EC2s, no provisioning, and no tuning compute clusters. Glue automatically scales based on the size and complexity of your job, so you only pay for what you use. One of Glue's most powerful features is the Glue data catalog. Think of it as a unified metadata repository that indexes all your data, whether it's in S3, Redshift, RDS, or elsewhere. It integrates seamlessly with services like Athena, Redshift Spectrum, and Lake Formation to provide consistent, discoverable access to your data. With crawlers, you can automate schema discovery. Just point a crawler at a data source, and Glue will infer the schema, create or update your catalog, and handle schema changes over time. This is especially useful when working with semi-structured formats like JSON or Parquet. For ETL workloads, AWS Glue offers multiple job authoring options. You can write jobs in PySpark or Scala, use Python Shell for lightweight scripts, or go completely no-code with Glue Studio's visual interface, which lets you drag and drop transformations and build pipelines visually. Glue supports a wide range of data formats and data sources out of the box, from S3 and JDBC to DynamoDB, and handles structured, semi-structured, and nested data with ease. It also includes built-in workflow orchestration, so you can chain together jobs using triggers and define complex dependencies using Glue workflows, or even integrate with step functions for more control. And finally, because it's part of the AWS ecosystem, Glue plays well with other services, from monitoring with CloudWatch, to access control via IAM and Lake Formation, to integration with Athena, Redshift, and SageMaker. It's built for performance, scale, and operational simplicity. AWS Glue is made up of a set of tightly integrated, yet independently usable components, each designed to streamline a specific part of the data integration workflow. Whether you need metadata management, data transformation, orchestration, or no-code prep, Glue has a modular building block for it. At the core of it all is the Glue data catalog. This is your centralized metadata store. It keeps track of table definitions, schema versions, and data partitions, and it's accessible not just within Glue, but also from Athena, Redshift Spectrum, and EMR. Feeding into the catalog are Glue crawlers. These crawlers scan data in S3, JDBC sources, and other repositories to automatically infer schema and keep your metadata up to date, minimizing manual work and supporting schema evolution over time. Glue jobs are the engine of data transformation. You can write distributed ETL jobs in PySpark or Scala for large-scale processing, or use Python shell jobs for lightweight tasks like calling APIs, generating logs, or pre-processing files. For scheduling and coordination, Glue offers triggers and workflows. Triggers can fire on a schedule or in response to events, while workflows allow you to chain together multiple steps, perfect for orchestrating complex multi-stage pipelines. To make all this accessible to a wider audience, AWS provides Glue Studio, a visual interface where you can build and run ETL pipelines using drag-and-drop blocks, no deep coding required. And for business users or data analysts, there's Glue Data Brew. This is a no-code data preparation tool with over 250 built-in transformations, helping teams clean and enrich data through a point-and-click interface. Together, these components form a robust data engineering platform. But here's the key. You don't have to use them all together. You can use just the data catalog with Athena, or just Glue jobs within a step functions flow. AWS Glue is modular, flexible, and built to integrate into your data ecosystem, however you need it to. This visual illustrates the end-to-end architecture of an AWS Glue deployment, showcasing how data flows from various sources through cataloging and ETL processing to reach analytical consumers. We start on the left, where data is generated and collected from a variety of sources: structured databases, unstructured data stores, and even real-time streaming feeds. All this raw data flows into the platform, ready to be transformed. Next, AWS Glue crawlers step in. They automatically scan these diverse data sources, extracting and inferring schema details. This critical metadata is organized into the Glue data catalog, creating a unified, searchable inventory of your data assets. Each dataset is now represented as a table, making it easy for downstream processes to discover and access the information they need. With the data cataloged, it's time for transformation. AWS Glue ETL jobs take over, running serverless, scalable Apache Spark scripts to clean, enrich, and reshape your data. For those who prefer a visual approach, Glue Data Brew provides an intuitive, no-code interface, letting users interactively prepare and cleanse data without writing a single line of code. As data flows through these ETL processes, it's written to Amazon S3, organized into logical zones: raw data, transformed data, and curated data, each stage representing a higher level of readiness for analytics. Finally, this well-organized, high-quality data is made available to a wide range of analytics tools. Amazon Athena enables interactive SQL queries directly on your data lake. Amazon Redshift brings powerful data warehousing and complex analytics to the table. And Amazon QuickSight delivers rich business intelligence and dashboards, turning your data into actionable insights. From raw ingestion to refined analytics, AWS Glue orchestrates every step, ensuring your data journey is seamless, automated, and ready for innovation. At the heart of AWS Glue is the Glue Data Catalog, a fully managed, centralized metadata repository that serves as the brain of your data lake architecture. The catalog acts as a single source of truth for all your datasets, storing schema definitions, table metadata, partition information, and data location references. It replaces the need for separate metadata layers across tools and services, helping unify your data ecosystem. One of its most powerful features is its integration with Glue crawlers. Crawlers automatically scan data in Amazon S3, JDBC sources, and other storage systems to infer schema, detect partitions, and populate the catalog with up-to-date metadata. This means you no longer have to manually define schemas or track schema changes over time. Once cataloged, your metadata becomes immediately usable across the AWS Analytics stack. Athena, Redshift Spectrum, EMR, SageMaker Data Wrangler, and Lake Formation all read from the same catalog, enabling consistent schema definitions and simplified access management across services. The Glue catalog also supports schema versioning and partition management. It automatically tracks changes to schema definitions and allows version rollback if needed. And by recognizing partitions, like year, month, or region-based folders, it optimizes query performance for large data sets. Security is baked in. Using IAM policies and lake formation, you can enforce fine-grained access control down to the column level. This is essential for meeting data governance and compliance requirements in multi-team or regulated environments. Need to share data across regions or accounts? The data catalog supports that too. And with federated queries through Athena, you can extend this capability to hybrid sources, making it easier to manage distributed data estates. Finally, the catalog is fully programmatic. You can create, update, tag, and query metadata using the AWS SDK, CLI, or API, making it perfect for automation, DevOps pipelines, or integrating into your broader data governance workflows. AWS Glue crawlers play a crucial role in automating metadata management within your data lake architecture. They eliminate the manual effort typically needed to define and maintain table schemas, especially when dealing with semi-structured or fast-changing data. Crawlers connect to your data sources, like Amazon S3, JDBC-compatible databases, or DynamoDB, and automatically infer the schema by sampling the data. They identify data types, field structures, and even partition keys based on your folder organization. You can run crawlers on a schedule, on demand, or programmatically as part of a pipeline, giving you full control over when and how metadata is refreshed. This is especially useful for both batch processing and real-time use cases. One of the standout features is custom classifiers. These allow you to define rules for parsing non-standard or domain-specific data formats, ensuring that even complex or nested files are properly understood and cataloged. Crawlers shine when working with semi-structured data, like JSON, Parquet, Avro, ORC, or XML. These formats often have deeply nested schemas, and crawlers can handle them with ease, flattening or preserving structure based on your use case. They also detect and map partitions from your folder structure, say year, month, and day, and register this information in the Glue data catalog. This enhances query performance dramatically, especially for tools like Athena or Redshift Spectrum. When data evolves, crawlers can detect schema changes and update the catalog accordingly, maintaining a version history. This means your pipelines stay resilient and aware of evolving data without manual intervention. And with support for incremental crawling, Glue minimizes the resources and time needed by scanning only new or modified files since the last run, making it highly cost-efficient at scale. With metadata tagging and integration into the broader Glue ecosystem, crawlers provide a critical foundation for data governance, discoverability, and automation. When working with data stored in Amazon S3, folder structures often represent partitions, like year, month, or region. AWS Glue crawlers automatically detect these folder-based partitions and map them as column partitions in the Glue data catalog. This enables your datasets to be query-ready without manual configuration. Crawlers are also built to handle multi-level and deeply nested partitions. Whether your data is structured by region, date, or product line, the crawler will correctly interpret the hierarchy and assign it to the appropriate partition columns in the table schema. As new data lands in your S3 bucket, crawlers can perform incremental partition detection. That means they only scan and register new or modified partitions since the last run, making the process faster, more efficient, and cost-effective. You also get flexibility with customizable partition keys and inference rules. If your folder naming doesn't follow the typical key equals value pattern, you can define custom logic to ensure partitions are correctly recognized and labeled. One often overlooked but critical feature is schema consistency checking across partitions. If the data structure changes within a partition, the crawler can detect mismatches and log warnings, ensuring that your metadata remains clean and reliable. Once partitions are identified, they're automatically integrated into the Glue data catalog, making them immediately available to downstream tools like Athena, Redshift Spectrum, and EMR without additional setup. And here's the real benefit. Partition awareness boosts performance. Query engines use this metadata to skip scanning irrelevant data, significantly reducing I/O and speeding up analytics workloads. Finally, using glue crawlers to scan S3 partitions helps enforce data lake best practices. It brings automation to metadata hygiene, encourages structured folder layouts, and ensures your data remains accessible, consistent, and performant. AWS Glue ETL lies at the heart of modern cloud-native data pipelines. It's a fully managed serverless ETL engine, which means you don't have to worry about provisioning or maintaining infrastructure. Under the hood, Glue ETL runs on Apache Spark, giving you access to a distributed, high-performance engine for processing large volumes of data with speed and reliability. It supports both batch and streaming use cases. Glue offers two primary types of ETL jobs. You can use Spark-based jobs for heavy lifting and complex data transformations, or choose Python shell jobs for lightweight scripting, automation, or integration tasks. This flexibility lets you build pipelines that suit a wide range of performance and complexity needs. For transformations, Glue provides both Spark data frames and dynamic frames. While data frames are familiar to Spark users, dynamic frames are optimized for semi-structured data and provide helpful features like schema inference and transformation tracking, perfect for evolving datasets. Out of the box, Glue can read and write to a wide variety of formats and sources, from Parquet, Avro, and JSON to relational databases, Redshift, DynamoDB, and S3. Glue bridges the gaps across your data ecosystem. You can author ETL logic using Python or Scala, or you can use Glue Studio, the no-code visual interface, to design, test, and deploy ETL pipelines without writing a single line of code. This democratizes ETL development across your team, from data engineers to analysts. Every job comes with built-in monitoring and logging, thanks to integration with Amazon CloudWatch and Glue's Job Console. You can trace job runs, troubleshoot errors, and optimize performance in just a few clicks. AWS Glue ETL is also tightly integrated with triggers and workflows, allowing you to orchestrate complex, multi-step pipelines that respond to events or run on a schedule. This means you can manage dependencies, retries, and conditional logic without writing custom orchestration code. When working with AWS Glue ETL, one of the most powerful tools at your disposal is the dynamic frame. Unlike traditional Spark data frames, dynamic frames are purpose-built for semi-structured data, the kind you'd typically find in JSON, Avro, or nested Parquet files. They provide the flexibility needed to work with datasets where the schema isn't always consistent or fully known ahead of time. One of the key strengths of dynamic frames is schema inference and flexibility. You don't need to define a rigid schema before processing. Instead, Glue dynamically infers the structure during job execution, which is incredibly useful for dealing with evolving or inconsistent data sources. Glue also provides a rich set of transformation helpers specifically designed for dynamic frames. Functions like apply mapping, drop fields, resolve choice, and filter streamline common data prep tasks, so you can reshape, clean, and enrich your data with minimal boilerplate code. What really sets dynamic frames apart is their support for schema evolution and tracking. They can manage schema changes gracefully across jobs, enabling you to build robust pipelines that can tolerate minor upstream changes without breaking. If you need to tap into the full power of Spark, no problem. Dynamic frames can be converted to and from Spark data frames. This lets you blend flexibility with performance, using the right tool for the task at hand. Another major benefit is that dynamic frames preserve metadata, things like data types, source file info, and transformations, across each operation. This metadata tracking is critical for debugging, governance, and ensuring data integrity. Glue also includes powerful utilities for data quality management, like functions for dropping nulls, resolving inconsistent column types, and eliminating duplicates. These are vital when dealing with raw or uncurated data lakes. Finally, dynamic frames power the visual ETL experience in Glue Studio. If you're building jobs using the no-code interface, every transformation is underpinned by dynamic frame logic, making it easier for teams of all skill levels to collaborate on data pipelines. One of the key strengths of AWS Glue lies in its powerful and flexible transformation capabilities, the core of any ETL pipeline. It all starts with apply mapping, a fundamental operation that lets you map source fields to target fields, often with data type conversions. This is essential for aligning disparate schemas across your data lake and structured stores like Redshift or RDS. For data cleaning, Glue provides a rich set of built-in helpers. You can easily remove null values, drop duplicate rows, filter data sets, and even resolve ambiguous data types using the resolve choice method. These operations make it easier to standardize and sanitize raw data before it enters production systems. Beyond cleaning, Glue supports column-level operations. You can rename columns, drop unneeded ones, or add computed fields using inline logic in Python or Scala. This gives you the flexibility to transform your data into exactly the structure you need downstream. For relational operations, Glue allows you to join datasets using standard join types, such as inner, outer, left, and right joins. And if you're working with deeply nested JSON or semi-structured formats, the relationalize function can automatically flatten and convert them into a relational tabular structure. When business logic gets complex, Glue doesn't hold you back. You can embed custom user-defined functions into your transformations, applying domain-specific rules or enrichment logic right inside the pipeline. Performance and query optimization are also part of the picture. With Glue, you can partition and bucket your output data, improving both query performance and data organization in your lake or warehouse. Another major advantage is the ability to implement incremental ETL patterns. You can configure your pipeline to process only new or updated records, making your jobs faster and more cost-efficient, especially when running frequently. Once your AWS Glue ETL job is ready, the next step is execution, and Glue gives you powerful flexibility here. First, you can choose between two job types: Spark jobs, which are distributed and ideal for processing large-scale datasets in parallel, and Python shell jobs, which are great for lightweight tasks like orchestration, data validation, or calling APIs. Now, how do you run these jobs? You can execute them on demand, based on a schedule, or using event-based triggers. Triggers and workflows in Glue allow you to build complex data pipelines that react to changes in your data lake or chain jobs together as part of a larger process. One of the most powerful features is job bookmarking. Glue can track previously processed files or data slices and skip them in future runs. This allows for incremental ETL, only processing what's new, saving time and compute costs. You can also pass custom job parameters at runtime, whether it's a date range, environment flag, or dynamic input path. This gives your ETL logic the flexibility to adapt to changing requirements without modifying code. Job performance is optimized through scalable worker configuration. You can choose from different worker types like standard, G1X, or G2X, and even enable auto-scaling of executors so your job adapts to the volume of data being processed. And when things go wrong, AWS Glue helps you stay resilient. You can configure retry policies and custom error handling logic to automatically manage transient failures or known exceptions in a controlled manner. Finally, Glue provides valuable execution metrics and lineage tracking, allowing you to monitor data volume processed, job duration, and resource usage. This also integrates with the Glue data catalog, helping you maintain end-to-end visibility of your data flow. With these tools, AWS Glue makes executing and managing ETL jobs not just scalable and efficient, but also transparent, flexible, and production-ready. A key strength of AWS Glue is its ability to orchestrate complex data workflows end-to-end. At the heart of this capability are Glue workflows, which let you string together multiple ETL jobs and triggers into a cohesive pipeline. These workflows can represent the entire lifecycle of data, from raw ingestion all the way through to transformation and delivery, making it easy to visualize and manage each stage of your data flow. To ensure your pipelines are production-grade, Glue includes built-in support for retry logic and error handling. This means if something goes wrong, like a temporary network failure or a data formatting issue, you can configure automatic retries or branch your workflow to handle failures gracefully. Glue also supports both event-driven and schedule-based triggers. Whether you want to run jobs on a daily cron schedule or respond to real-time events like the arrival of a new file in S3, Glue has you covered. You can also use conditional triggers to run jobs only after certain upstream jobs complete successfully or fail. For more advanced orchestration needs, AWS Glue integrates seamlessly with AWS step functions. This enables you to coordinate Glue jobs with other AWS services, like Lambda, SageMaker, or DynamoDB, using a state machine to manage logic and execution flow across your entire data platform. Throughout the process, you get integrated monitoring and visualization in the AWS Glue console. You can easily see the status of your workflows, follow job execution in real time, and troubleshoot failures directly from the interface. And if you need deeper observability, Glue works with Amazon CloudWatch Events and EventBridge. This allows you to monitor events across your AWS ecosystem and trigger downstream processes or alerts based on pipeline activity. Together, these orchestration tools turn AWS Glue from a powerful ETL engine into a fully automated, reliable, and intelligent data platform orchestrator. AWS Glue Studio is designed to simplify the creation and management of ETL jobs, making it accessible to data engineers, analysts, and even those without deep coding experience. At the heart of Glue Studio is its drag-and-drop visual interface. Users can quickly build end-to-end ETL pipelines by connecting sources, transformations, and targets right on the canvas, eliminating the need to write complex PySpark from scratch. Glue Studio supports a wide range of data sources out of the box. Whether you're ingesting from Amazon S3, Redshift, RDS, or JDBC-compatible databases, you can configure connections directly through the UI with just a few clicks. Once data is ingested, transformations are handled visually as well. You can apply mappings, filters, and joins, or manipulate columns and data types using pre-built transformation nodes. And for more flexibility, custom transforms can also be added within the visual flow. A standout feature is schema preview and validation. At each stage in the pipeline, Glue Studio lets you see the shape of your data, making it easy to spot issues early and verify that your logic is working as expected before you hit run. Behind the scenes, all these components are powered by AWS Glue dynamic frames, which handle schema flexibility and semi-structured data more gracefully than traditional data frames. And when you're ready to scale, Glue Studio offers the best of both worlds. You can generate the PySpark script from your visual job for versioning or advanced customizations, giving you the flexibility of code with the ease of a visual builder. With Glue Studio, building robust, production-grade data pipelines becomes faster, more intuitive, and far less error-prone. Now let's take a moment to talk about AWS Glue Data Brew, a powerful bonus tool in the AWS Glue ecosystem that empowers users to clean and prepare data without writing a single line of code. Data Brew features a no-code visual interface that makes it easy to explore, transform, and prepare your data for analytics or machine learning. With over 250 pre-built transformations, users can perform complex operations like filtering, deduplication, string manipulation, pivoting, and more, all through an intuitive, spreadsheet-like UI. One of DataBrew's core strengths is data profiling. As soon as you load a dataset, you get immediate insights into missing values, outliers, data additions, and patterns, enabling faster issue detection and cleanup even before you run an ETL job. And it's not just a standalone tool. DataBrew integrates seamlessly with the AWS Glue Data Catalog, so all your metadata remains consistent across Glue jobs, Athena queries, and other AWS analytics services. It also connects to a wide range of data sources, including Amazon S3, Redshift, RDS, and JDBC-compatible databases, giving users the flexibility to work with data wherever it lives. DataBrew is especially valuable for citizen data scientists and business analysts, users who need to explore and wrangle data without relying on engineering teams. It helps remove bottlenecks and promotes self-service analytics across your organization. And when you're ready to move data into a machine learning pipeline, DataBrew excels as a pre-processing engine, helping prepare features and normalize data before feeding it into tools like SageMaker. What's more, every transformation you apply is captured in a reusable recipe which can be versioned and scheduled as part of an automated workflow, bringing structure and repeatability to the data preparation process. Glue Data Brew brings visual power, analytical insight, and usability together, making it an excellent complement to your Glue-based data lake architecture. In any data engineering workflow, ensuring data quality is not just a best practice, it's critical. AWS Glue provides several built-in and extendable mechanisms to help you enforce data integrity and catch issues before they impact downstream systems. It all begins with data profiling, and Glue Data Brew makes this step highly accessible. Data Brew lets you visually analyze your datasets before ETL jobs run, detecting missing values, outliers, and duplicates. This upfront visibility helps catch data anomalies early in the process, reducing debugging time later. But profiling is only half the story. Glue Data Brew also supports custom data quality rules at scale. Whether you're checking for values within a numeric range, applying regex patterns to validate formats, or using conditional logic to flag inconsistencies, you can create a comprehensive validation layer that runs automatically. For actual data cleanup, AWS Glue provides built-in transformation operations in both Glue Studio and Data Brew. You can easily apply cleansing routines like null value handling, consistent formatting, deduplication, and type conversions, all without having to write custom code. To maintain data consistency across your pipelines, schema validation and enforcement is crucial. The Glue Data Catalog acts as a central metadata layer where crawlers and jobs validate the structure of your data. If a schema drifts unexpectedly, for example, a column disappears or changes type, Glue can detect it and raise flags. Quality isn't just about the data, it's also about how it's organized. That's where partition hygiene and metadata validation come in. Glue ensures that partitions are properly registered, schemas are up to date, and metadata remains query efficient for tools like Athena or Redshift Spectrum. And for those with more advanced or custom validation needs, Glue supports integration with external tools. Using Python shell jobs or AWS Lambda functions, you can plug in proprietary logic or third-party APIs to check for business-specific rules or perform advanced validations. With these layered capabilities, AWS Glue empowers you to build reliable, trusted, and high-quality data pipelines at scale. Security and governance are foundational pillars when working with data at scale, and AWS Glue provides a comprehensive set of tools to enforce them effectively. First, IAM roles and fine-grained policies allow you to tightly control who can access Glue jobs, crawlers, and the data catalog. You can restrict permissions at the resource level, ensuring only the right users and roles can perform specific operations. And to further streamline permissions, you can use tag-based access control, which lets you manage access using tags, such as environment, project, or business unit, rather than hard-coded policies. Data security doesn't stop at access control. Glue supports encryption at rest using AWS KMS for everything from job bookmarks to data stored in S3. In parallel, encryption in transit ensures that all data moving between services is secured using TLS. For even more granular security, AWS Glue integrates with AWS Lake Formation, giving you the ability to define column level, row level, and table level permissions. This enables true fine-grained access control across your entire data lake environment, down to specific fields in a table. When it comes to metadata, you can apply strict access policies directly to the AWS Glue Data Catalog, ensuring only authorized users can view or modify schemas and metadata definitions, safeguarding the structure of your data assets. For network-level security, AWS Glue supports AWS Private Link, allowing private connectivity to services like S3, Redshift, or RDS without ever leaving the AWS network, reducing exposure to the public internet. And finally, all activity within Glue can be audited using AWS CloudTrail. Every API call and event is logged, enabling full traceability for compliance reviews, anomaly detection, and forensic investigations. AWS Glue offers a flexible, consumption-based pricing model designed to scale with your workloads. At the heart of it all are data processing units, or DPUs. Your build per second, with a 1-minute minimum, based on how many DPUs your ETL job consumes during execution. This makes Glue ideal for dynamic, on-demand data processing tasks. To help you better align costs with performance, Glue supports different worker types. These options let you tailor compute and memory resources based on the size and complexity of your jobs, so you're not overpaying for unused capacity. Glue crawlers, used for schema discovery and metadata extraction, are billed separately, based on the number of DPUs used and the total crawl duration. This means frequent, broad crawls can add up, making it essential to scope them efficiently. The AWS Glue Data Catalog includes a generous free tier, up to 1 million objects and 1 million requests per month. Beyond that, you'll incur charges for both storage and API calls, so it's important to manage metadata hygiene and remove unused entries. Visual interfaces like Glue Studio and Glue Data Brew come with separate pricing models. For example, Data Brew charges by session and per data row processed, making it important to understand how these tools fit into your workflow before running large jobs. Also note that job bookmarks, used for incremental ETL and development endpoints, which are great for debugging and custom development, may introduce additional costs depending on their usage. In summary, while Glue is serverless and pay-as-you-go, understanding how each component contributes to your bill is key to keeping costs in check, especially at scale. As you scale up your data workloads with AWS Glue, optimizing for both performance and cost becomes essential. Let's walk through some of the best practices that can help you achieve that balance. First, take advantage of job bookmarks. These let Glue remember what data has already been processed and skip it on subsequent runs. This is a game changer for incremental ETL workloads. It reduces runtime, limits resource usage, and ultimately keeps your AWS bill in check. Next, consider the trade-offs between dynamic frames and data frames. Dynamic frames are great for schema-evolving data and come with rich transformation options, but they can introduce a performance overhead. On the other hand, if your schema is well-defined and stable, using Spark native data frames can give you better performance through more optimized execution. Tuning for parallelism and worker configuration is also crucial. AWS Glue offers multiple worker types and lets you control the number of workers. Choosing the right combination ensures you're not over-provisioning resources for small jobs or underpowering large ones. Another smart optimization is to use push-down predicates. These allow you to filter data at the source, especially useful when connecting to JDBC or Redshift, so only relevant records are pulled into memory, saving both processing time and cost. Don't overlook the importance of retries and timeout settings. Long-running or stuck jobs can silently rack up charges. By setting intelligent retry policies and timeouts, you can avoid runaway compute costs and ensure cleaner failure handling. To keep tabs on your job health and efficiency, monitor everything with CloudWatch metrics. Glue provides out-of-the-box metrics like job run times, records processed, and error counts, perfect for visual dashboards and alerts. And for deeper performance tuning, don't forget the Spark UI. It gives you insights into job execution plans, data shuffles, and skew issues, so you can optimize bottlenecks at the Spark execution level. When building production-grade data pipelines with AWS Glue, monitoring becomes critical. AWS CloudWatch logs provide detailed execution logs from your Glue jobs, crawlers, and workflows. These logs capture everything, from informational messages to stack traces, making it your first stop when investigating job failures or debugging custom scripts. Alongside logs, CloudWatch metrics track the health and performance of your Glue components. You can monitor key indicators like job runtimes, the number of data processing units consumed, trigger success or failure counts, and more. Within the Glue console, you'll find real-time job details and execution graphs that visually map out the stages of your ETL jobs. This gives you an intuitive view into progress, bottlenecks, and error points without having to dive deep into raw logs. For deeper analysis, AWS Glue ETL jobs provide access to the Apache Spark UI through the Spark History Server. This is incredibly useful for diagnosing performance issues like stage retries, task skews, or resource bottlenecks inside complex transformations. Monitoring extends even further with job bookmark tracking, which lets you validate incremental processing behavior, ensuring your pipeline processes only new or changed data without missing segments. Beyond Glue itself, Amazon EventBridge can capture job and workflow events, such as jobs started, succeeded, failed, or timed out, enabling automated responses like sending alerts, kicking off remediation workflows, or updating dashboards. And finally, Glue monitoring doesn't have to stay within AWS. Many organizations integrate Glue job telemetry into third-party observability tools like Datadog or New Relic via CloudWatch, extending visibility into centralized operational views. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. and thank you for watching.